Alrighty, welcome back to Fun Maths. Alright, today we're looking at the applications of matrices, in particular looking at simultaneous equations and how we can handle that with matrices. These are the things that you absolutely need to know. It says in simultaneous equations the number of unknowns is equal to the number of equations. Yep. So if you have got 3 variables or unknowns, you will need 3 equations. This will pop up in an example we'll do a bit later on, but it's important to know that if you've only got 2 equations and 3 unknowns, then that's not going to work with this. It says the value of each unknown can be found using algebraic methods of substitution and elimination. So they're alternate ways in which you can do simultaneous equations. However, in further maths, we are looking at using matrices to solve simultaneous equations. Now, generally speaking, if you've got some equations, you're going to have some coefficients that are numbers in front of the variables. In this case, x and y are the variables. We've got some numbers that will be in front of them, which are a and b, and that'll be equal to something. That's the first equation. Second equation here, again, you've got the variables x and y. You're going to have a coefficient in front of each of those. It's denoted by the c and the d, and that's going to be equal to something. Now, if you have some simultaneous equations like that and you need to pop them into a matrix format, here is how it's going to look. So in the first matrix here, you're going to have the coefficients that are the numbers in front of the unknown variables. So we've got the a and we've got the b here. They're listed. In the second row, you're going to have the coefficients of the second equation. The number or coefficient that's in front of the x variable here is c, and this one is d. Make sure when you're popping these into a matrix, you take note of the sign on that as well. So if it's a negative value, obviously place that in front of there. Write that as a negative value into that matrix. The next matrix here is where each of the variables are listed. We're dealing with x and y here. They are listed as follows. After the equal sign here, we're going to write down what each of those is equal to. The first equation was equal to this value here, e, so it gets written first, and the value of the second equation, what it was equal to, is written here. Again, if you had 3 variables or 3 unknowns, you're going to have a 3 by 3 matrix here, and you'll have the 3 variables listed in this particular spot here. There'll be an extra row, and here you'll have an extra row as well. If we're thinking about what each of these matrices are called, this one here would be matrix A, this one here would be x is equal to matrix B here. Now, if we refer to them as such, it says where A is the coefficient matrix, which are all the numbers that are in front of the variables. These are going to be the coefficients of x and y. X, this one here, is the matrix of the pronumerals, as we had a chat about, using that simultaneous equation, and B is going to be the numbers on the right hand side of the simultaneous equations. Cool, we already spoke about that. Happy days. Again, if you want to find out what x is, it says here we need to multiply both sides by the inverse of a, and that is using the multiplicative inverse of a. And again, if you multiply this side before the x, so you're pre-multiplying it by the inverse of a, you have to pre-multiply this side by the inverse of a. So if you multiply before the x on this side, it has to be done before the b on this side. So it's important to do that, and we'll have a look at an example. Some other things, it says it's possible to have equations with 3 or more unknowns. I've already spoken about that. You'll need 3 or more simultaneous equations to find out those values of the unknowns. If you are going through this particular case and you work out the determinant, and that determinant comes out to being equal to 0, then that's significant. So what it will mean is either there's going to be no solutions, which is that's the graphs of the equations are parallel to each other, so they're never going to cross over. So there's no solutions in that particular case. Or there are an infinite amount of solutions, that is, there is no unique solution. If there's an infinite amount of solutions, it's the same equation, they are drawing the same line. Next thing to note is it says if the graphs of the equation are parallel, it's also known as inconsistent equations, then there will be no solution. And as we said here, the determinant of that matrix will be 0. Likewise, if the graph of the equations draw the same line, which are known as dependent equations, then there will be an infinite amount of solutions. That is, you're not going to get a unique solution, and again, the determinant of that matrix will be 0. Alrighty, the last thing as well I want to talk about is the fact that you can have some worded questions where we're going to use matrices to solve them. There's some tips or some steps that I'd like you to follow when we are going through them. So what you need to do is, first of all, read the problem several times to ensure that you fully understand it. Sometimes the wording can be challenging and you need to really be careful with that. Next step is to identify the unknowns and assign appropriate pronumerals for that. And when you are doing that, remember, as we've said at the start, the number of equations is going to be equal to the number of unknowns. Last but not least, we'll identify statements that define the equations and write out the equations using pronumerals. Cool. Alrighty, let's now have a look at some examples. Alright, the first one here, it says use matrix methods to solve the following equations. We've got some simultaneous equations. Again, you'll note that there are 3 equations here, and they have the variables x, y, and z. And we've also got what each of those is equal to. So the first thing we need to do is actually put this into matrix form. So first thing I'm going to do is write down the coefficients into a matrix. So there's 3, so it's going to be a 3 by 3 matrix. So for the first equation, even though it's not written there, we know that's one lot of x. So there's a 1. In front of the y variable, it's a negative 2. And in front of the z, it's a 1. Positive 1, even though it's not written there. For the second equation, the variable, or the coefficient, sorry, in front of the x is negative 2. We've got positive 3 lots of y. And you'll notice straight away they're trying to trick you a little bit here. There's no z variable. So in this particular case, when there's no z variable, you do need to do something about it. Indeed, this particular case, you need to write down that there's 0 of those. The last equation here, we've got 2 lots of x, so the coefficient is 2. Again, there's no y variable in the third equation, so you must put down the 0. And we've got negative z here, which means negative 1 lot of z, so put there negative 1. Next, we're going to write out what those variables are. We're dealing with x, y, and z's. Then we're going to write down an equal sign and what each of those are equal to. So the first equation was negative 2, this one was negative 3, and this one here was 4. Cool. So that's the first part, is actually just setting them up into the matrix format. Now, you should remember, as we said a little bit earlier, this here could be matrix A, this could be matrix X, and this could be matrix B. Again, if you are rearranging things, you need to do the inverse before the X on this side. It means you need to do the inverse before the B on this side, which will rearrange to this matrix here is equal to the inverse of A multiplied by matrix B. So that's how we would solve that one. So let's actually now go ahead and do that. So we've got matrix X, which was this one here, X, Y, and Z. And that's going to be equal to the inverse of A. So again, here we've got a 3 by 3 matrix. You would use your calculator in this particular case to work out the inverse of that. So again, you punch it into your calculator. If you're using a ClassPad calculator, you do the little up hat to the power of -1 and it will work out the inverse for you. For the moment, we're just going to write this out using that notation. So I'm writing it out. So that's to the inverse, -1 there. So that's the inverse of A. That gets multiplied by this matrix B. -2, -3, and 4. So as I was saying, on your calculator, you would type in this matrix to the power of -1. That gives you the inverse of that. And then you would multiply it by this matrix here, which is matrix B. Once you've put this on your calculator and you've worked it out, you will end up with the following. You get 0, -1, and -4. Now, again, some people attempt to just to sort of leave it there and move on to the next question. What I would really encourage you to do is actually write out what the answer is. So I would say the values of the pronumerals they are, and I'll actually list what they are. X was equal to this first one here, which is 0. Y was equal to -1. And Z was equal to -4. Cool. We have answered that question using simultaneous equations, but using matrices. Okay, the next question says here, use a matrix method to decide if the simultaneous equations have a unique solution. Alrighty, here is how we'd go about doing this. I would put these simultaneous equations into matrix format. So again, doing that, you're going to have the coefficient matrix. So the first line is going to have the 2 and -1 lot of y. So you've got the 2 and -1. The second row of the coefficient matrix is going to have, there's a 1 lot of x there, and another 1 lot of y. Next, we're going to write down the variable matrix. We're dealing with x and y's. Okay, this is equal to, the first one was 8, and the second one was 1. So again, to work out this particular equation, what you would have to do, if this was matrix A, this was matrix B, this was matrix X, and this was matrix B, you'd have to rearrange things like we did before, and you'd be working out, to work out X, you'd be the inverse of A multiplied by matrix B. Again, so with a 2 by 2 matrix, we should be able to do that by hand, and we had the chat about this the other day. So what you need to do to work out the inverse of a 2 by 2 matrix is first of all work out the determinant. So let's work out the determinant of matrix A, remembering that it is A, D, take away B, C. So in this case, A was 2 and D was 1. So 2 times 1, take away B, which is -1, times C, which is +1. In this case, what it does simplify down to, you end up with 2 times 1, which is 2, take away -1 times 1. -1 times 1 is -1. 2 take away -1 is the same as 2 plus 1. So it's +3 that we are looking at there. So really in this particular case, it says use a matrix method to decide if the simultaneous equations have a unique solution. The good news is because this is not a 0, it's an actual value, then a unique solution can be found. So I'll just write that here. So I'm just going to say, making a mess here, since the determinant of A is not equal to 0, a unique solution can be found. Cool. Now, again, some people, if they're not reading the question carefully, would rush ahead and actually try and work out what X and Y are and things like that. But this question wasn't actually asking you to do that. It was just asking whether they had a unique solution or not. So once we've worked out the determinant and we see that it's not a 0, then you can say, yes, a unique solution can be found. Let's have a look at this next one here. Again, you would set it up into the following equation. 2 and a 4 for the coefficients of the first one, 3 and a 6. We're dealing with X and Y. Here is what they are equal to, 12 and 8. First thing to work out obviously is the determinant of this matrix here. So that's AD take away BC. So A times D, that's 12. Take away 4 times 3, which is 12. 12 take away 12 is 0. Oh, okay, so in this particular occasion, since the determinant is equal to 0, I'll write that here, is equal to 0, then a unique solution cannot be found. Cool. One last question for us to have a look at. Oh, cool. It is a worded example. Nice. What's happening here? Oh, it's the bakery. Cool. It says here, a bakery produces 2 types of bread. We've got wholemeal and we've also got rye bread. Perfect. It says the respective processing times for each batch on the dough making machines are 12 minutes and 15 minutes. So that means, respective means it's 12 minutes for the wholemeal and it's 15 minutes for the rye on the dough making machine. Likewise, it goes on and talks about the oven. The oven baking times respectively again are 16 minutes for the wholemeal and 12 minutes for the rye. The question goes on and asks how many batches of each type of bread should be processed in an 8-hour shift so that both the dough making machine and the oven are fully occupied. Alrighty. Now, we had the chat before about the steps to deal with these types of questions. First is to read the question a few times and to understand it. And then the second part, is to identify the unknowns and also to assign appropriate pronumerals there to that. I'm going to now assign the variables. I'm feeling very adventurous today. I'm going to label them as X and Y. Yep. So I'm going to say let X, and we're going to let X represent the number of batches of the wholemeal bread. So the number of batches of the wholemeal bread. And again, I'm very adventurous, so I'm going to let the other variable be Y, and we're going to let that be the number of batches of rye bread. Perfect. Alright, now that we've got those variables, we need to create some equations. Now, we've got 2 variables that we want to work out. So what we need to realize is that we need 2 equations. Yep. So let's get those 2 equations. The other thing I want to talk about before we set up these equations is the fact that we're dealing with minutes here for the baking times and the oven times, and then we're talking about an 8-hour shift here. Before we set up these equations, we want them to be both the same units of measurement. So what we'll do this question in minutes. So if we think about an 8-hour shift, you need to know how many minutes there are in an hour. You then need to know how many minutes there are in 8 hours. Okay, there's 60 minutes in an hour. You've got 8 hours. That's going to be a total of 480 minutes. So, first equation we're going to set up here is for the dough making machine. You've got 12 minutes to do the wholemeal bread, plus 15 minutes to do the rye bread in the 8-hour shift. So let's write out an equation for that. 12 of x plus 15 minutes for the rye, which is, the variable is y, and you've got the 8 hours to do that, which is 480 minutes. The other equation we're going to create is based on the oven baking times. It's 16 minutes to do the wholemeal bread, so 16 times x, and it is 12 minutes for the rye bread. And again, you've got 8 hours to do that. Cool, we've got two equations there. Again, we're going to put those into matrix simultaneous matrices to solve. So we'll write the coefficients in this first one here. We've got the 12 and we've got the 15. They're the numbers in front of the x and the y, the variables. For the second equation, we've got the 16 and the 12. We're dealing with x and y because I came up with those variables. You could have came up with other things. You could have been more creative and come up with w and r or whatever. Here, they were both equal to 480. Alrighty. Now we need to solve this. So again, consider this being matrix A, this being matrix X, this being matrix B. Rearranging so we can get X by itself, you'd have to do the inverse of A to the left-hand side before the X. Therefore, we need to do the inverse of A before the B over this side. So you'll end up with X is equal to the inverse of A multiplied by matrix B. So this matrix X will be X and Y, this one here. That's equal to the inverse of A. So you have to actually go ahead and do the inverse of A like we did before with these particular questions. In this particular case, the inverse of A is equal to the following: 1 over negative 96. And then obviously these flip around, the 12 swaps with the 12, and the sign changes on these two here. That was positive, it becomes negative. This becomes negative also. So that's the inverse of A. Remember, it's 1 over the determinant and then swapping the things around. And then that's multiplied by matrix B. Perfect. We can now simplify things down, multiply these two matrices together. You'd end up with 1 over negative 96. These two multiplied together gives us the following. So that's negative 1,440, and this one here is negative 1,920. We can then divide each of these by negative 96, and you end up with 15, and you end up with 20. So the solutions in this particular case, x is equal to 15 and y is equal to 20. But to actually write this out and answer the question nicely, I would say the following. To utilize the machine, over the 8 hours, you could create 15 batches of X, which were the whole meal. So over the 8 hours, you create 15 batches of wholemeal, and you would create 20 batches of rye. So to utilize the machine over 8 hours, you would have 15 batches of wholemeal, 20 batches of rye should be produced. Cool. Again, thank you very much for listening. Good luck with these types of questions. Bye for now.